This example is on inventory management, the quantity discount model, and the problem is on the baby strollers. The handout is on Blackboard. Manufacturer of baby stroller purchases the seat portion of a stroller from a supplier who lists these prices per seat. So basically the supplier is giving the manufacturer a price list, a schedule of prices. And so the price schedule, we call it, is something that is very common. The more you buy, the less the price. And so if we look at it from the problem, you can pay $5 per seat if you buy a quantity less than 500. If you buy between 500 and 1,000, then you pay $4.90, so you get a break of 10 cents. If you buy between 1,000 and 2,000, then you get a break of 20 cents, so $4.80. And if you buy more than 2,000, then you get $4.70. This is what we call price schedule. The ordering cost is represented as S. That's $50 per order. Every time you place an order, it's estimated at $50. The annual demand is big D, is 8,900 seats per year. And the holding H, the holding price, is 0.3 times the purchasing price. So the holding price is dependent on the purchasing price. When you read in your book, there are two ways to represent holding price. Holding price could be constant, or holding price could be dependent on purchasing price. So this is the case where holding price depends on the purchasing price. It's not constant, so not constant. Okay, so the very first thing you want to do is, and I really highly recommend it, is draw a graph. Quantity on the x-axis, total cost on the y-axis. And you want to draw a graph for the total cost. We know from the simple EOQ that the total cost is a curve that is a trade-off between ordering and holding, and it comes to be a curve that looks like this, because ordering and holding work against each other. So it's a curve that looks like a cup, and it has a bottom line, a bottom point, and that's your EOQ quantity. And there is a formula for that, and that's how, if there is one price, that's how you calculate it, and that's your optimal quantity to order every time. But that assumes that the quantity is constant. Here we don't have a fixed price. We have 4 different prices, so what we're going to get is 4 different total cost equations. So we're going to get a total cost equation. The highest would be at 5, then followed by total cost at 4.9, total cost at 4.8, and total cost at 4.7. And then we're going to get what we call price break quantities at 500, at 1,000, and at 2,000. Okay, and let's draw the lines here at these price break quantities. Okay, so if you look at this, apologize for my graphing, but you get the idea. So if I buy more than 2,000, then I can buy it at 4.7. So this part of the graph is what's important, correct? None of this is important. So if I buy between 1,000 and 2,000, then I pay the price of 4.8. So now this part of the graph is what's important. This doesn't apply. This doesn't apply. And then if I buy between 500 and 1,000, then this part of the graph is what's important. This doesn't apply. And this doesn't apply. And if I buy less than 500, then I have to pay the highest price, which is the $5. So none of this is important. Okay, so what we end up with is a disconnected graph. It's what we call a step function graph. It's disconnected. It's the bold pieces. So it's like I start here, I take a step up, I go here, I take a step up, I go here, I take a step up, and so on. So, so then the simple equations that are made for with the EOQ quantity when the price is fixed do not simply apply here. So we have to apply what you call an approach, a model, an algorithm that will help us find the optimal solution. So, so to find the optimal solution, the optimal quantity to order, we need to follow a solution approach, a model, if you will. And what is this model? This model goes as follows. Your book describes one way of doing it. I'm going to describe here my way of doing it. Either one will work. It doesn't matter how you do it. But this is my way of doing it. I start at the lowest total cost curve. So that's P equals to what? 4.7. So think of it like you start at the lowest step, if you will. And I calculate, since H here depends on P, I go ahead immediately and calculate the H. That's 0.3 times 4.7. And so that's going to be 1.41. Okay? So I calculate the EOQ quantity for this total cost curve. So the EOQ quantity for this total cost curve is 2SD over H under the square root. That's the bottom line of the cup of the 4.7 total cost curve. So that'll be 2 times 50 times 8900, correct? Divided by the 1.41, all under the square root. So that gives you 794 units. So then you ask, is 794 units, is that feasible? Is it feasible? Is that feasible? Meaning, is it on the dark line? Is it, can you buy 794 at the price of 4.7?